What if everything you know about electricity is wrong? When you flip a light switch, something strange happens. The room lights up instantly. No waiting, no visible movement, no delay. Yet you are told that tiny particles, electrons, are traveling through miles of wire from a distant power station to your home. How fast are they moving? Here's the shock. Slower than a crawling ant. So how does the light turn on immediately? This is the great misconception about electricity, and it troubled even the best physicists for generations. Feynman once said that people don't understand electricity, not because it's too complicated, but because we explain it wrong. What we imagine is not what actually happens. The pipe fantasy most people picture electricity, like water in a pipe. Turn on the switch, electrons rush through the wire, bulb lights up. It feels intuitive, it feels mechanical, it feels obvious, and it is completely misleading. Feynman warned that this analogy, while convenient, hides the real physics. Because if electricity were truly like water flowing through a pipe, nothing would work the way it does. A light bulb 1,000 kilometers away would take minutes to turn on. But it doesn't. It turns on almost instantly. So what's really moving? Electron drift. The slowest surprise in physics, electrons do move. But painfully slowly in a typical household wire, drift speed, less than 1 millimeter per second. That's slower than growing fingernails, slower than tectonic plates, slower than the hour hand of a clock, yet the effect of electricity travels near the speed of light. This contradiction is where misunderstanding begins. What actually travels through the wire? Feynman emphasized this point again and again. It is not the electrons that matter, it's the field. Electricity is not about particles traveling from place to place. It is about energy transfer through electromagnetic fields. The moment you flip a switch, an electric field reconfigures itself. That change propagates outward at near light speed. Energy flows through space around the wire. Not inside it. The electrons barely budge. They just wiggle.
The wire is not the highway.
Here's the twist almost nobody teaches early on. The energy does not travel inside the wire. It travels in the space around the wire, guided by a bit. The wire's job is not to carry energy. Its job is to shape the electric and magnetic fields. The wire is a fence, not a pipe. A dangerous oversimplification. The water analogy wasn't meant to deceive, but it created powerful illusion. We began to think electricity is stuff. It flows like liquid. The battery sends electrons to the bulb. Feynman called this kind of thinking cargo cult understanding. You can recite the steps, you can solve the equations, but you don't see what nature is actually doing. And nature, as always, is stranger than the story we tell. The battery myth. Another misconception. The battery is not a storage tank of electrons. There are already electrons everywhere in the wire before the battery is even connected. The battery doesn't push electrons forward. It creates a difference in electric potential, a tension in the field, like stretching a rubber sheet. The moment the circuit closes, the field snaps into a new configuration. The electrons respond locally. The energy moves globally. Why this matters? This isn't just philosophy. Misunderstanding electricity leads to confusion about power transmission, electromagnetic radiation, signal propagation, even modern computing. To understand electricity is to understand how information and energy move in the universe. And the universe doesn't move the way our intuition wants it to. Why Feynman hated simple explanations. Richard Feynman was famous for explaining difficult ideas simply, but there's a difference between simple and wrong. He once said, if you think you understand electricity, you probably don't. The deeper physicists went, the less electricity looked like a thing, and the more it looked like a relationship, the electric field, the invisible actor. An electric field is not a substance. It's not made of particles. It's not something you pour or store. It's a mathematical description of how space responds to charge. When a field changes at one point, that change spreads. That spreading is the signal. That spreading is the energy transfer, the speed limit of reality. Nothing travels faster than light. Electric fields obey this rule. So when you flip a switch, the field change travels outward at roughly 300,000 kilometers per second through space surrounding the wire. That's why lights turn on immediately, E miles away. Magnetism. Magnetism is the other half. Whenever electric charges move even slightly, they generate a magnetic field. Together, electric and magnetic fields form a single entity. The electron expresses energy, momentum, and information. And it doesn't need matter to exist. Energy flow happens outside the wire. This part shocks engineers the first time they learn it. The direction of energy flow is given by something called the pointing vector. Pointing is perpendicular to both electric and magnetic fields. From the power source to the load, through space around the conductor, the wire simply guides the fields, like rails guiding a train that never touches them. Why thick wires matter? If electrons barely move, why does wire thickness matter? Because thicker wires reduce resistance, alter field geometry. Waste less energy as heat, again, not because electrons move faster, but because the field configuration becomes more efficient. The heat illusion. When a wire heats up, people think electrons are crashing like cars. Not quite. The electrons oscillate, they scatter. They interact with the atomic lattice. The energy is transferred from field to matter, not from fast particles smashing forward. AC power and the dance of fields, alternating current, makes this even clearer. In AC, electrons don't travel anywhere. They vibrate back and forth. The field oscillates. Energy still flows forward. Travel. Motion without displacement. But this is where classical intuition collapses. Electricity is a conversation between space and charge. Feynman didn't believe nature hides behind mystery, but he accepted that nature doesn't care about human intuition. Electricity is not a substance. It is not a current of things. It is how space reacts when charges are present. Why we keep getting it wrong? We evolved to understand rocks and water, not fields. Our brains want objects' motion, causes we can see. Electricity offers none of these. Instead, it offers rules, relationships, equations that describe behavior. But not pictures the brain likes. The universe runs on fields. Once you understand electricity, you see the pattern everywhere. Light is an electromagnetic wave. Radio signals are field oscillations. Wi-Fi is energy propagating through space. Matter itself is built on quantum fields. Electricity is not special. It's a preview of how everything works. Feynman's final lesson. Feynman once summarized physics brutally. What I cannot create, I do not understand. To understand electricity, you must abandon comforting metaphors. No pipes, no flowing stuff, no magic particles racing down wires. Only fields, only rules, only consequences. That's the big misconception. Finally stated clearly, electricity is not the movement of electrons through wires. It is the rearrangement and propagation of electromagnetic fields through space, guided but not carried by matter. That single correction changes everything. Why this matters beyond physics, understanding electricity correctly helps us understand. Why signals don't need matter. Why energy can exist in empty space. Why reality is deeper than objects. Why the universe is mathematical at its core. Electricity is not a thing we use. It is a relationship we participate in. Closing thought. The next time you flip a switch, don't imagine something flowing. Imagine space rearranging itself. Imagine invisible fields snapping into a new geometry. Imagine the universe responding instantly, without effort, without struggle. That is electricity. And according to Feynman, that's the kind of understanding that actually matters.